Hi, I'm starting a video series where I talk about some naughty behavior I encounter when writing C and C++ programs. The first one I want to talk about is the fdset macro. And this macro is being used with the select syscall. The select syscall essentially allows you to monitor multiple file descriptors and return once one or more of them are ready. The way you pass in the descriptors to the select syscall is that you first create an fdset, then you set it to all zeros, and then you call fdset to set this descriptor in the set. And in this example I'm simulating that you're calling the accept syscall, which is returning a socket. In this case the descriptor is a socket, and then we set it in the set, and at the end we call select with the set. However, there is a big caveat when using fdset, and it's mentioned in this line. It's basically saying that you cannot use descriptors with values that are bigger than or equal to the fd set size constant. And this constant on my machine has a value of 1024, and this is something specific to the glibc implementation. I think there are two really big problems with this limitation. The first one is that the descriptors you're going to set usually come from the system itself. For example, you're calling the accept syscall, which will return some descriptor. We're using some other kinds of descriptors that you get from the system itself. What I mean is that you don't have control over what the values of these descriptors are. And having a limitation while you're getting the descriptors from the system itself is a really bad thing. I think it makes select totally useless in cases where you have lots of descriptors. And the second issue here is that the way it fails if you set a value of a descriptor that is bigger than or equal to fd set size is the worst possible. It's essentially a stack corruption, which I'm going to show you in a second. One could think of different ways for this to fail. Maybe the set could have a limited number of descriptors that it supports, but the values themselves could be arbitrary, and maybe the select syscall would just fail with an error code saying that the descriptor number is too big or something like that. But unfortunately this is not the case. So let me show you what happens when you run this program. We're going to compile it with the other sanitizer to see what happens. So let's run it. And as I was mentioning, we're getting a stack buffer overflow, which is something you're only going to get once the descriptor's value itself is more than 1023. It's even worse that maybe you will not even notice it most of the time, and at some random point in the program's runtime it will just corrupt the stack and you have no idea what's happening. To understand why this is a stack overflow, let's look at the fdset type and the fdset macro. So basically the fdset type is just an array of 16 elements of type fdmask, and the fdmask itself is a wonk. And this is just a bit set essentially containing 16 wonks. And if you multiply 16 by 64 on this machine, 64 being the amount of bits in a wonk, you'll get 1024. So this is kind of an array of 124 bits. And now let's look at the fdset macro and why this is actually a stack overflow. So what the fdset macro is doing is first indexing the array and then setting a specific bit in this integer. And since the array has capacity for 1024 bits, if you try to set the 125th bit, then you're going to be out of this array on this line. And that's how you get a stack buffer overflow. Finally, I just want to say that, to be fair, the man page mentioned this is a bug. However, this limitation, especially coupled with the fact that you get descriptors from the system itself, makes select useless and even dangerous. I think the morale of this story is to never use low-level APIs and use higher-level libraries like Boost or similar, or maybe even consider using different languages, where such a nasty corruption cannot happen. Implementers must have had a good reason to impose this limitation, but I'm thinking facing that in 2021 is something we can avoid. Thank you for watching and see you next time. Bye bye.